So hopefully this time we'll make it generic enough that we don't end up having to rewrite this shit. It's always really annoying when that turns out to be the case. Q of these, Q of those. Current, not dot data. Q of those. Total path, not reverse. It doesn't work because we need to add system.link for that to work. Okay, there we go. So this is going to properly rebuild the path at this point and store it into path so that we've got that. Okay. Oh, we call this cost estimate func instead of that for neighbor. So the is goal check, you can, in the words, Project Porcupine version, this was a delegate. I think because the goal tile could be a little bit funkier because of the way jobs and things were handled. For here, we can just, for our goal check, we can just say, if current is equal to end tile, then we're at the goal. So we can just reconstruct the path in a way that's going to be useful for our units and then just bail. So, are we there yet? Yes, we're there. We're done. So, the thing that's missing here is the current.edges. Edges are really the neighboring connections. So, this is really something like this. For each of our neighbors, we're going to loop through each one of our neighbors and then try to keep pathfinding from there. Get neighbors is definitely going to need some internal caching in our implementation, but that's something we can worry about later. So the only line that's got an error left at this point is this one right over here. Neighbor, well, we can get rid of the data, but pathfinding cost. So we need to know how expensive it is to enter this tile. Actually, I think pathfinding cost is the cost to date. That might be the, I think anyway. It's the only reference to pathfinding cost. That's part of the data. Which is our base tile info. Really? Where is our tile info? I don't remember where that got stored in our old thing. Can I just search a repo? Tile.cs, where are you? Nowhere. Where the hell's our tile class? It should not be hard to find, but things have been moved around a lot since the last time I worked on it. Inventory, job, keyboard, order actions, not under prototypes. Ship settings, scheduler, trade. Ah, it's under buildable. Sure, okay. Oh, that's why it's a little bit weird. So pathfinding cost is set up as a property, so it's got some logic and things like that. Okay. But this is one of the big differences between Project Porcupine and what we're trying to do here. The pathfinding cost, like the movement cost to enter a tile, is not constant. So instead, it's something like this. Our pathfinding cost is going to be equal to the neighbor dot also who's decided to spell neighbor without a U? Aggregate cost enter, which is going to be the cost so far. We're gonna have to figure out so that's our G-score current, followed by source tile, which is current, followed by the unit, which we have here. So I'm going to rename this as well. This is going to be total pathfinding cost to neighbor. Times distance between. That's interesting. This must be to handle diagonal movement cost. So that moving diagonally, yeah, okay. So we don't need to worry about that. So what we have is the total pathfinding cost from start to this neighbor. Okay, this is the important thing, is in our variant, this is the total pathing cost from the start to the neighbor. So it factors in the existing cost to move to current tile, which is current along our path, right? Current, like initially current is the start tile, but at some point this is later in the algorithm. So from the current tile, it's got a cost for us to have reached there, and now we were passing that in and saying, okay, so our neighbor, this is the cost. We're moving from this with this unit into this tile. That's going to give us total over here. So what we no longer need to do is we no longer need to add the current G-score to this. We're just going to store it in there. That's going to be fine. We're going to see if the neighbor was already in our list and it had a... Oh, if this neighbor tile is already in the list and our current score that we just calculated is bigger than its existing score, then we're just going to continue. We've just checked a tile that we've already found a way to reach, but we found a way to reach it cheaper in the past. So we're just going to drop out of it. No more, no caring about that. So that's the continue. We're just going to skip this one. Otherwise, if we get here, this is either a new tile, or we just found a cheaper route to it. So we're going to update the came from. So to get to this neighbor, oh my god, that spelling is driving me bonkers. Wait, is that even... Now, it's like, you know when you look at a word too much and it doesn't look right anymore? Excellent. Gotta have a U. The O is driving me just nuts. It's the little things, you know? So anyway, we're going to make sure that the came from array says, to get to this neighbor, we came from this tile over here. The cost to reach this neighbor is this. And the estimated cost through this neighbor to our final destination is the current cost plus the cost estimate function over here, which is basically all the same, and done. And then we've got to reconstitute. So if we try to compile, we've got an error here. Oh, right. The cost estimate function needs... Oh, it needs the end tile. There you go. So we're estimating the cost to go from this neighbor to our final destination over there. Compile again. No errors. Doesn't mean we don't have any logic errors. Right. These are not supposed to be IQ. Thanks for pointing that out. I got like too used to typing the I. That's supposed to be Q path. And tilegraph isn't supposed to exist at all, right? Probably, but there we go. Thank you very much for catching that. That was not right. So this is an interface, interface, interface. The others are not interfaces. I just started liking typing IQ. Okay. So there's probably some logic errors, but they were mostly there. So what we should do is something like, we'll do a test little run of our clicking. So we want to, our dummy pathfinding function is going to be something like get hex at. Oh, right, our neighbor getting code doesn't work. Like, or hasn't been implemented. There's interactual hex. Like, we've got the functions, but they're just going to throw exceptions. We need these things to actually, do stuff. But let me get back to that in a second. So we're going to take our existing hex dot, so it wants what? X plus Y. So current hex dot, so it shouldn't be X plus Y, but a column plus 5 and hex dot row. There we go. So we're going to set up a pathfinding job whenever we call this, which we'll dummy something in here for a second, to try to pathfind 5 tiles to the right and then see if we can get that to go. Probably because I've got some stupid dummy code, I think, in here for when we hit the space bar. These are just all testing stuff. So same thing. If input dot get key down key code dot p, there we go, then dummy, oh, is it not public? Probably not public. So I mean, this is just going to result in some errors right now for sure, but that's okay. Dot dummy, there you go. So if I hit P, it'll try to run the pathfinding code for this unit to move 5 tiles to the right, which will throw a bunch of exceptions. And that's okay. Oh, there we go. Oh, I need to make sure to save these after renaming stuff. I need to rename the actual files here as well. Nope, sorry, that was fine. Never mind, everything's okay. So that's all right. So if I hit play, it is assigned a value but never used. Do we actually not need to reference the world? That's interesting. Suppose that might be true. So if I hit P, there we go. I was going to say, come on, give me an error. There's supposed to be a goddamn error. There's supposed to be an earth-shattering kaboom. Oh, I don't call do work. Haha, that's why there's not an earth-shattering kaboom. Because I never actually call the do work function. Because we're doing things slightly differently from before. QPath over here. It calls the resolver, and then we're going to call .do work right away. We're getting the error on get list. But that's not where I'm expecting the earth-shattering kaboom. For all I know, we'll even hang the program or do something else that's glorious like that. P. There we go. Okay, not implemented exception. So it's complaining that it's trying to call this get neighbors at some point, and this get neighbors does not exist. So this is going to be one of the other great advantages of, well, I guess it doesn't matter that much. As I said, great advantage of the cubic representation of our hexes, but it doesn't really matter. Because our neighbors are thus, right? We're going to set up, so an array of hexes, neighbors, spelled, the awesome way. And it's going to be an array, of size 6. Well, let's make a list temporarily. It's going to be okay. New list hex. And so what we're going to do is we're going to say that neighbors dot add. So we're going to get, we've got our hex map, get tile at, or hex at. So we're going to say there's going to be one where the x is +1 and 0. All right. So there's going to be 6 of these. Column to the left, column to the right. There's going to be 2 that are above and 2 that are below. But here's where the number's a little bit weird. We need the let's see here. +1. I kind of like it this way. +1, -1. And then we have +1, -1. Like that. And then finally we have +1, -1, and -1, +1. Those are our 6 neighbors. Now the thing is, some of these might be nulls. Right? Because if we don't allow looping, we actually could get a null if we're looking to our north. That's entirely possible. So we don't want to just blindly add it this way. Or do we? I guess what we could do, because you can add nulls to a list. And then, I guess after we do that, we could loop through each of these. You know, and then remove the nulls. It's kind of a little stupid and awkward, though, right? No, it's probably okay. Tell you what, we'll make a second list. I'm sure there's a better way to do this, but it's starting to get a little long. So for each hex h in neighbors 1, if h not equals null, then neighbors 2 dot add h. Oh my god! H. And then what we're doing is we're returning neighbors2.to array. But one of the things I don't want to do is keep having to recalculate this, especially since apparently I've done it like in a really stupid way. We can fix this later. But the thing ultimately is we want to save these because your neighbors don't change. So we're quite happy to say something like we're going to have a hex array which is going to contain our neighbors. And we're going to do this. If neighbors not equals null, then we just return neighbors. Done. And what we're actually doing over here is we're setting neighbors. Sorry, this should be the actual neighbors array. Setting it to that, and then returning this dot neighbors. That way. So we're going to do this recalculation that way. There's a way to do it better, but we're going to have to do it once ever for each hex. We're going to save the array. After we're done, we're going to save the array right here. And the next time we call get neighbors, we just return it right away. And we're groovy. So I could have written it better, but this is going to work just fine. So now we're going to get a different not implemented exception. Hit play. Hit P. These two errors are fine. That's saying we're looking for x's. Oh, wait, hold on. Q plus. Did I? You know, it would be very handier. Because I was going to go, you know, Q plus 1 all the way down here. I guess that's still fine. We could have just overloaded some operators and made life a little bit sweeter too, but I guess this is going to be fine. Row, row. I know there's like excessive signs, but that's totally okay. There we go. Because otherwise it was assuming we're looking for the neighbors of tile 0, 0. So now it's going to be our neighbor offset by a certain amount. Or our tile offset by a certain amount. Because those errors were fine, except that they did indicate I was using the wrong thing. Okay, so now we're getting a new not implemented, because this aggregate cost enter is throwing an exception. Luckily, implementing this is super easy, because we're actually just calling the unit dot because this is the thing with the aggregate, right? Oh, we'd have to cast it. I suppose I could just move. Can I just move all this code over to the other thing? Fuck it. I already wrote it here. It's fine. We're going to take the unit, cast it as our actual unit type. and call aggregate turns to enter hex. So we're going to be entering this text, and the cost so far is going to be that. We actually, right now in our current implementation, we don't care about the source tile. To do, we are ignoring source tile right now. This will have to change when we have rivers. But we're just going to do this for now because we've got this code written, so we're going to return this. So cost so far. So we're entering this tile, passing it the cost so far, and it's going to return the total cost that we've already, in theory, worked out in the past. It's probably wrong, but that's okay. Hit P. Okay. We're getting all these warnings about floating point drift. So I should have actually, like, returned what the values were to get some interesting info. Turns to date. Boop. Oh, you're returning 0. That's... Oh. I'm an idiot. This is a little thing I put in because I assume at some point, especially if we have units with like a movement rate of like 3 or something like that, or roads or something like that, I think there's going to end up being weird floating point things, and I just want to be warned about it. But here we got to check. If turns to date is above 0 but less than this amount, then that's when we want the warning. It was triggering whenever it was 0 as well, which is... Shh, it's fine. I just hit P and nothing... No errors occurred. We, of course, don't have any messages either. So, just for the record, this is presumably all running. Are we doing anything with it? That's an interesting question. We may just not be saving our info. Yeah, we're not. Set hex path. Well, tell you what, let me just... P is equal to that, just to say. Set hex path to H. No, sorry, to P. Do something like debug.log got pathfinding path of length p.length. Oh, yeah, we are going to force the cast this. Anytime you're doing these forced casts, it's not necessarily ideal, although on the other hand, I don't know, maybe it's fine. Cannot cast from source type to destination type. Why though? This returns an array of IQ path tiles. Oh, you have to cast on like a case-by-case basis? You can't just cast the whole array and pretend? Is that possible? Use link.select. Hey, I want to say a great big thank you to all the June Patreon supporters and these Mic Check supporters. We've got Yukofin, Eric Sumner, Tiburon, Mighty Mix, Pavel Zdanov, Drazion, Michael McClintock, Aaron Toyson, Craig Mortel, The Not So Evil Engineer, Julien Auger-Lafont, Marius Fieldvold, Speedy Savant, Valiant Cake Fiend, Thomas Oberson, Jason Yanity, Stephen Bonnerman, Kale the Quick, and Neil Blakey Milner, and absolutely everyone who watches, shares, favorites, and subscribes to these videos. Thank you so, so much.